So this problem is worked out on a separate sheet, but I thought I would just take a few minutes and kind of explain more of what's going on. So the first thing you need is the net ionic equation. And because we found that all the silver gets used up, basically there's no silver left at the end of the reaction. So the chloride ion is going to be the excess reagent. So we can find out the moles that we have of silver. This is the number of moles of silver that are actually going to be used up. So we multiply the volume times the molarity, and that gives us 0.020 moles of silver. So that's silver used. And then the next thing we need to do is we need to find out how many moles of chloride ion we had to begin with. So we started with 0.1 liters, and we multiply that times the concentration. The trick here, or the modification that we have to make, is there are 2 chloride ions for every 1 mole of CaCl2. So we have to take that into account. So when we do that, we get the number of moles of chloride ion. So this is the amount of chloride ion, the moles of chloride ion that are present at the beginning. So then the next question is, how much is left over? So if we start with 0.030, and then we're going to use 0.020, because the silver and the chloride ion react in a 1-to-1 ratio. So 0.030 minus 0.020, and that's going to give us the leftover chloride ion. So that's just going to be what? It's going to be 0.010. The other thing that we have to take into account is we have to know the total volume. That is, we've combined 2 solutions. So if we want the concentration, we need the volume. So we already have the number of moles, and we just need to find the volume. So we started with basically 0.1 liters of each solution, so 0.1 and 0.1, so that's going to give us 0.2 liters. And then after we have the total volume, we'll divide the moles of chloride ion by that total volume, and then that will give us the concentration of the chloride ion. So that's just going to be 0.01 divided by 0.2, and that's going to give us 0.05 molar solution. So again, 0.01 divided by 0.2, which is the total volume. So 0.05, actually that should be moles per liter, okay? And then that's just 0.050 molar. So that's the concentration of the chloride ion after the reaction. The silver ion is used up, so that concentration is 0, and then we just have the spectator ions to deal with. So for the spectator ions, if we look back up in the equation, we can see that for the nitrate is the same number of moles as the silver ion, so that's 0.020 moles. And again, then that's going to be divided by the total volume. And that gives us a concentration of 0.10 molar nitrate ion. And then for the, what was our other ion, other spectator ion? Oh yeah, sorry, the calcium ion. So the calcium ion is the same as the moles of calcium chloride. So it's 0.015 molar calcium ion over 0.2 liters. That's going to give us 0.75 molar. Okay, so it's not anything new or different. It's just a couple of additional calculations just to see what's left over in terms of concentration.